Hello, hello, and welcome to this evening's codeLive all the way from Australia. For those new to codeLive, it's an opportunity for developer advocates like me to come along and present on a feature or capability, something that we find interesting to the community. And it's live, so we encourage you all to ask questions, make jokes, or introduce yourselves to each other in the chat. By way of very brief introduction, my name's Dave Norris. I'm a developer advocate at Salesforce specializing in data cloud. And in the next 30-ish minutes, we're going to cover not only how to build predictive AI models, but also a question I'm getting a lot from the community is how do I use those predictions in a meaningful way? So we're going to pick a use case and hopefully make that interesting for the next 30-ish minutes. I've picked an APAC-friendly time. As I said, the idea is to bring the community together, get you to introduce yourselves and ask any questions live as we go through. So I promise to pause occasionally and I'll check the chat for any questions or any funny jokes you want to share. Before we get started, probably is something I should share with you all, and that is the forward-looking statement. So don't make any purchasing decisions on any forward-looking statements I might make, only on what's generally available. All right, I'll check the chat very quickly. I can see a familiar face already. So, hi, Niket. It's good to be back on codeLive after a while. Last time we came and did something on integration, I believe. So it's nice to come back and do something for Data Cloud. So hopefully you find this interesting. Okay, I'm going to switch to a demo. And since I'm not really a big part of the demonstration, I might hide my face just so I don't distract anyone in the bottom right-hand corner. So the topic was building predictive AI models and making use of the outcome. The best way for me to do that is not show you any slides. We're just going to go through a use case together. And the use case I've picked is a not-for-profit use case of an animal rescue center. And you can see here that I've just created some very simple custom objects in Salesforce that represent animals that have been through the rescue center. We can go down and have a look at a record. And you can see that we've got some basic information on the animal. I'll zoom in a little bit so people can see. So things like the type of animal. In this case, we've got cats and dogs, breed, whether they're healthy, the size, fur length, the fee that was charged, if applicable, for adoption, number of photos for the website, things like that. And just like most objects in Salesforce, they'll have related information. So for animals, that would be things like medical records or perhaps behavioral checks that the animal's been through. So one way that's very in focus right now is the use of Agentforce to make micro tasks easy whilst using Salesforce. And I think one way we can showcase this straight away is if we open up Einstein and we perhaps just ask for a summary of the animal. So nothing to do with predictive AI yet. But one thing I don't want to do in the animal rescue center is I can't possibly be across hundreds of animals. So it's nice to have the ability to summarize not only the details, but also the related information. So not only the related list, but things like tasks and emails. So here we've got a nice way for me to get familiar with these animals with an overview, and it's summarizing the related information from the related list, things like the behavior checks that were done, any open medical records. And I've even asked it to give me an estimate on recovery time for specific operations or procedures. And then even the tasks, emails, things like that. So that's a starter for 10. But I think we can do a little bit better than this. I think we can probably add predictive AI, because really what I want to know is not the summary of an animal, but I really want to predict the chance of this animal being adopted. Because if I could do that, it enables me to take mitigating action, because how long an animal stays in the rescue center impacts things like staffing, how much food I need to bring in. So Let's have a look at how we can do that together. So I'm going to disappear again, and I'm going to move into Data Cloud. The first thing I'm going to do is, if I'm going to start making predictions on the chance of an animal being adopted, I need some historical data, because predictive AI is really about learning from the past to predict the future. And if the animal center has had hundreds, if not thousands, of animals through the center over many years, and they have the adoptive outcome as a value that I can track, then I can use that historical data to train a model that we can start predicting what the adoption outcome might be for new animals coming into the rescue center. So in Data Cloud, we have the concept of data streams. We're not going to cover the basics here. There are lots of great videos and blogs around to get familiar with what data streams are. But I've really just ingested the custom object we've just seen into Salesforce into Data Cloud, and I've called it animal. And in fact, what we can do is we can use Data Explorer. Let's go and have a look at the data model object that was created when that data stream ran. So it just pulled information from Salesforce into Data Cloud. So we can see here, these are the attributes that came from our custom object. So things like age, the name, the breed, these are all of the fields we saw from the custom object in Salesforce. But one additional column that we could bring in is whether the animal was ultimately adopted or not. And it's a yes or no value. So this is the historical data. When we say historical data, this is exactly what we mean, because I can use this data model object now to bring in, to make predictions on the chances of an animal being adopted. So to do that, we're going to move to Einstein Studio. And we're going to do this together. We'll do it live. So I'm now in Einstein Studio, and I'm in Model Builder, which is on the left-hand side here. And we're going to create a predictive model together. So there's a button here called Add Predictive Model. I'm just going to click that, and we'll go through the steps together. Now, the first thing is, if this rescue center had made a strategic investment in hyperscalers, so they already had predictive models that were in SageMaker or Vertex AI or Databricks, I could actually reuse those investments here. But a question I get asked a lot is, what if we don't have investments in those hyperscalers? Does that preclude me from using predictive AI? Well, technically not, because you can build and customize your own models without writing any code. So that's what we're going to select here. We're going to create a model from scratch together. First question I have to ask myself is, where is the data that I'm going to use to train my model? And for us, we're going to use the animal data model object. So this is the one we just ingested from Salesforce, and it had that adopted column, yes or no. So that's the data we're going to use. We'll click next. Next decision I have to make is, what are the records I want to use to train the model? I can filter if I want to, or use all the records. You can see here that we have about 10,000 records in this data set. I'll just leave it at all records. The next question is, which field or column in that data set would I like to predict values for? And we know we have a column called adopted that I can use to train my model. And I want to maximize the chance of the adopted value being yes. So pretty straightforward. This has already been identified as a binary classification predictive model. So it knows it's true or false, yes or no. And in this case, it's the yes or no option. We'll click next. Now we have to decide, what are the variables that we're going to use to train our model? So what variables do we think are going to have a material impact on an animal being adopted? So we can let Einstein or Autopilot search through and select them for us, or we can deselect it and include the variables we want. So breed, fur length, the color of the animal, whether it's vaccinated or not, the overall health, how many photos were taken. So we could go and select all the variables that we thought were pertinent. I'm just going to let autopilot select for me. And then we can select the algorithm that's going to be used for our predictive model. So again, we can let Einstein pick the best algorithm based on the binary classification and the variables we've chosen, or we can override it if we want. So here we can see it's going to use XGBoost. Once I click next, I'm going to get a summary page. And this is going to show me a summary of everything we've selected, and then I'm ready to train my model. So when I click save, I can then just give the model a name and hit the save and train button. So even if you don't have skills or data scientists at your company, it shouldn't preclude you from trying to get insights into your data. This is a very simple use case that hopefully gives you some insights into how you might do it for your industry or your particular use case at your company. Now, if a question I get commonly asked is, what if we want to select the algorithm specifically, or we want to have more control over our data, or we want to start comparing different models? That is where I would probably be making an investment in the hyperscalers like Vertex AI and SageMaker that give me those capabilities. But I do need a different skill set and obviously a monetary investment. Okay, so let's pretend I've clicked save and train. In this data set for 10,000 records, it was taking about 20 minutes to train the model. So I'm sure you don't want to watch a spinner go round for 20 minutes. So I've already trained a model for us. Let me just go back. I'm just going to check the chat window quickly. Oh, nice to see people from Switzerland coming along. I hope it's hope it's not too early in the morning or late at night for you. But nice to meet you. Thanks for joining. So I've already created the model here. We literally went through it, the same steps I've just shown you. I called it the animal adoption model at the bottom here. So I'm just going to click into it. The first thing I'm going to want to do after I've run through those steps and it's successfully trained the model is look at the performance, because I don't really know whether it is accurately predicting whether an animal is adopted or not. So I'm going to select the model and use this View Training Metrics button in the top right-hand corner. So here, I'll just come back on camera quickly. So this is a way for me to know if, or what it's effectively doing is it drops the adopted column from the training data set that we ingested. And then it uses the variables we selected to then try and predict that outcome itself. Now, what it does is after it's made the prediction, it then looks at the historical data, the actual value for adopted, and works out whether it was accurately predicting the right value or not. So that's really, in a nutshell, what we're seeing here. There are various metrics on this page that data scientists will be familiar with, but even if you're not familiar with the metrics specifically, I'll go through 3 that will be interesting. First one is the overall performance of the model. Now, contrary to popular belief, I don't actually want this value to be 1. If it was a perfect model, I've probably introduced some information into the scoring that's always predicting the right outcome, which is always not a good thing. So we want a high performance, but certainly not 1. Then I can see how often the model correctly predicted the adopted outcome. How often did it correctly predict no versus yes? And you can see here that it was the majority of the time, giving me some confidence that the model was performing. The other analysis that's interesting and will make sense to everybody watching is the top predictors. So based on the training that's been done on our data, let's identify the variables that have the biggest material impact to an animal being adopted, and it's ranked them for us. So in our data set, We can see that age is top, which isn't surprising. I'm imagining older animals are adopted more slowly or not at all. Breed would have an impact. And interestingly, we can see things like number of photos. So how many photos these people are taking for their website or for their marketing campaigns has a big impact. Interestingly as well, we can see things like fee. So how much I'm charging for an animal to be adopted has a lower ranking. So I can use these statistics straight away to start making business decisions. So perhaps we might start charging a small fee, knowing it's not going to materially impact whether an animal is adopted or not, to help cover the charges and rescue more animals. But I did promise that's sort of like the build phase of the demo. But the question I get asked isn't, now you've trained this model, what are the ways I can start using these predictions? There are several ways. There are three main ways. I can start running these predictions on data flowing into Data Cloud, and we can do that via a prediction job. I'm not covering that today, but if you're interested, then please check the documentation. So in batch or streaming, as data's coming in and changing animals, we can run a job that's going to run our prediction and then create a data model object we can query. The other way is using batch transformation. So if you're joining data model objects together, you can run the AI model prediction and start using outputs of that to segment your data, filter your data. What I'm going to focus on today is agent force. It seems to be a hot topic. But before I leave Data Cloud, one of the things I do need to do is look at this recommendation section here, because the prediction itself will be a percentage. It will be how likely is this animal to be adopted. But what would be more useful to frontline staff is what could I do to increase the chance of an animal being adopted? So if I open up this variable section, you can see here that I can go into the variables that we used to train the model, and I can decide which ones I want the model to tell me how they might impact the chance of an animal being adopted. And I've selected 4 here: fee, number of photos, sterilized, and whether they're vaccinated or not. Now, the reason I'm pointing this out to you is when I show you agent force later, you'll see this is important, because I don't really want the model to tell me to lower the age of an animal, because that's something that's not in my control. I don't really want the model to say, you need to change it to a more desirable breed, because whilst they do have a big impact on the adoptive outcome, it's not something that I can materially impact. So I'll stick to the 4 that I can. I can change the fee. I can change the number of photos I'm taking. I do have a choice on whether they're sterilized or not and whether they're vaccinated. Okay. Going to pause here. Do some questions. So I think we've got a couple of good questions in here. Is it like Einstein data discovery that also does predictions? Does something very similar. So where you can select recommendations and it shows you top predictions. The main difference here is where I'm taking action, which will hopefully become clear to you as we move into agent force. But if I haven't, then whoever this was, please loop back and let me know. And yes, follow up from the same person. That is really the main difference between the two. We're covering the actionable insights. So that's what you've got to bear in mind. Getting the value is one thing, but how are you going to use it to drive a business process? All right. Now we've trained our model. We've checked its performance. We've selected some variables that we want the model to recommend to us. Let's move into Flow Builder. So I am going to make use of this model in Flow. And again, that's the one we've predicted. We haven't used batch transformations. We haven't used prediction jobs in this use case, but we could. I've created a template triggered prompt flow. has very simple steps. I'm going to get an animal that's passed into it. So I'm going to query for an ID based on an animal that's passed in. And this is where I can add an action. I'll temporarily add one for you so you can see the motions you would go through. You'd add an element, you'd select action. On the right, you can see the groupings. Now we have data cloud as an option. And here you can see at the top the predictive AI models that I can select. So animal adoption model Einstein was the one that we were just watching earlier. Now, once you select that, if we select it now, you can see that it automatically knows the inputs to the model. These were the variables we used to train. And right at the bottom, look at what we can include. We can include recommendations and top predictors, which is exactly what I've done here. So we just delete this one and open up the one that was here earlier. You can see here that I'm just populating the inputs to the model from the record that's passed in and asking it to suggest 3 recommendations to increase the chance of being adopted. And the top predictors as well, because it's specific to each animal, not generic like we saw before. Then all I'm doing in the prompt template is I've got a very simple output here that includes the outputs of the predictive AI model. So we have the prediction, we have the recommendations, which is held in a variable called prescriptions, and the top predictors, which is held in the variable called factors. But just know these are all coming from the outputs from the model, and these are the 3 that you can choose from. So very easy not only to call, but also to start doing things with the output. So I'm using a prompt in this case, but hopefully you can see that you can use screen triggered flows, record triggered flows as well, to do a very similar thing. Okay, so we've got a flow, we've got the predictive model, we've created a flow that calls it, and it's going to retrieve the prediction, the prescriptions, and the factors, and give it back to a prompt. So I've created a prompt here. Again, prompt engineering is something that I definitely recommend everyone gets very good at, because I've spent a little bit of time here. Just put my beautiful Facebook and camera. A little bit of time here constructing a prompt that's going to use the outputs of that flow as effectively as possible. But even now, when I run it, the outputs change each time I call the large language model from the prompt. So I could probably even spend more time improving the output, but we'll see how we go. So I've instructed it that I'm going to get a JSON payload, and I want you to include sections for likelihood of adoption, include the prediction as a percentage and the top predictors, and always do a bulleted list, famous last words, and then the recommendations, again, as a bulleted list. And I've given it some guardrails on how concise it should be, what it shouldn't do, formatting guidelines with some examples. And you can see here, all I've had to do in the data it's going to use is link it to my prediction AI model output flow. So in theory, let's put in an animal here, because to test it, the flow needed an animal ID, and I got one I prepared earlier that I know has some decent data in. So I'm going to preview this prompt. So again, it's going to call the foundational model I have on the right. I'm using OpenAI's GPT-4 Omni Mini foundational model. I've played around with a few. This seems to give me the best response. And you can see for this animal, 11663, the likelihood of adoption is 17.18%. That's pretty useful, but what's more useful is I can see what negatively and positively impacts that prediction. So you can see here that this animal is 16 years old, so it has a negative impact. I can see that the number of photos that have been taken of the animal is 0, has a negative impact, but interestingly, their breed, domestic short hair, has a slight positive impact. And then this is the important part, the recommendations. Here for this animal, increase the number of photos taken to at least 7. So hopefully you can see how we've taken predictive AI model, we've added a flow, and now we've added it to a prompt. This sort of gets us some of the way, but I want to make it easier for users to use the prompt And one of the ways I can do that now is with Agentforce. So I'm going to take this prompt and we're going to build an action, an agent action together. So this is a way for me to build like an assistive agent, much like ChatGPT or Gemini is, that people can just chat with in natural language and get a response. How I did this, I created an agent action. I gave it an action type. So in this case, it was a prompt template. Then we can have the reference action. We called ours animal adoption prediction. And then you need to tell the large language model how to execute your action. So you have to give it instructions. So I should probably expand this a little bit, how it should, when it should use this action, and then the instructions. And this is where I'm going to say you need to pass in an ID. If you want any help on best practices for instructions, then I recommend the developer help section, which gives you some really good examples. The only other thing I need to do is obviously the ID is what the flow needs, and then I just need to show the response in the conversation. So I've already done that in the animal adoption prediction here. The last step needed is, or here it is, I might as well show you whilst I'm here. You can see here that the instructions I gave are a little bit more verbose. I was saying that you really need the single ID of an animal, and I've given it some examples of what to expect. Okay, and the last step is really with Agent Builder. So really what I want to do is create a topic, and a topic is a logical way for a large language model to find my custom action. So I give the topic a description. Here I'm describing that we're going to get the likelihood of adoption for a single animal record. And I've given it some examples of when the large language model should use this topic. So when someone are using terms like likelihood of being adopted or predictive adoption outcomes, I can give it a scope, and then I can give it one or more instructions. So in this case, I'm making sure that, because I need the animal ID, make sure that you always ask clarifying questions to resolve the record. And then once it's found the topic, I need to tell it which actions it can run. There are standard actions, and I've stolen a standard action here for my topic called identify record by name, because if someone doesn't give me an ID, they give me a name instead, which is going to be a lot more user-friendly. I want the agent to do the hard work of going to look up the ID. And then we've got our custom action here, which is going to execute our prompt, which we'll call the flow, and retrieve the data. So what it looks like, let's try and run this. So one thing I need to do once I've configured my topic and added my actions is test it. So I've just asked what's the likelihood of adoption for name, and then I've passed in the same animal we used for our prompt test. And what Agentforce should be doing is it should be working out a plan to get the ID of this record, then call my custom action, and then produce the output. So to go through that a little bit more slowly, the reason we test here first is you can sort of see the plan Agentforce has executed. It's taken my prompt. It correctly selected the topic based on the instructions I gave it. It then identified that because I gave it a name, it can't run my custom action straight away. It actually had to identify the record by name. So you can see here it's passed in the animal name and retrieved the corresponding ID. And it's then passed that ID into my prompt. And you can see here on the right, this is the output that we've trained it on. Again, likelihood of adoption. So it indicates a low chance of adoption, and you can see the same output, although each time you run it, it will be slightly different based on what the large language model is outputting. All right, so I'm nearly at time, and I don't want to keep people. I know 30 minutes is a lot of time you're giving me, but I want to show you from a user's perspective very quickly. Let's go find a different animal. We'll clear the conversation, make it easy for people to see. Let's find a collie dog. So once you've enabled your agent, I should just be able to ask in natural language Is this animal likely to be adopted, as an example? And again, just in the way similar way that we've just tested, Agentforce is searching for a topic, searching for actions needed, and then executing the output. So you can see here, I've picked a different record. Note that Agentforce understands the context here. I didn't have to put in an ID or a name. It's assuming I meant the animal I'm on. And you can see here that the predictive outcome is very different for this animal. It's got a high chance of adoption at nearly 98%. And it's telling me the top predictors were size. The fact it's young, only 1 year old, is a positive effect. And the color is popular. It's also telling me to increase that further, which is pretty impossible. Then I can start looking to increase the number of photos. You can see here that current photos is 5, and it's suggesting I include up to 9 photos. So that, in a nutshell, go back to show my pretty face, is not only how you can build a predictive AI model, but also how you can use it, specifically with, in this case, an assistive agent, helping the frontline staff not only get to know the animals, but now start to make material impacts to their chances of being adopted. So I can drive behavior, like take more photos, to frontline staff based on the prediction we made. I'm going to have a quick look for any questions that are being asked. Got one from Niket here. How is it different from Einstein Prediction Builder? So Einstein Prediction Builder was really built for Salesforce to run on Salesforce custom objects or standard objects. And now we have the ability with Data Cloud to run those predictions at scale with those built-in recommendations. And now we can take actions. Because remember, the data for these is often not stored in Salesforce. That's the example I used today, but it could be in Google, Amazon, Azure. So now you've got the flexibility to do that at scale, because typically you're going to have hundreds of millions of records, which often isn't a good fit for storing them in Salesforce. Thanks for some of the feedback. I've got a question here from Igor, which is very good. Can we save it in a field on the record? So that's a really great question. So at Dreamforce, the answer is yes. So at Dreamforce this year, we had a very similar predictive model for predicting a hotel reservation being cancelled. And it had to be the next reservation the customer had, because they might have multiple future reservations. So for that, we used a calculated insight, and we ran a prediction job. And the prediction job is going to output a data model object that I can use to join in that case, it was the customer, to the next reservation cancellation. And then I use those calculated insights in a copy field enrichment. So I could copy it directly into the contact record. So that's a good question, because it means that I don't always have to call out to the model. If I can save it in a copy field, then it's available to me and anyone else using Salesforce. Thanks, Igor. Good question. Steve, I'm probably pronouncing that wrong. Apologies. Thanks for the feedback. Good to see that you like the demo and not the slides. Niket as well, thanks for attending. Appreciate your time. Before I go, I am just going to do my best to encourage you all. If you like content like this, make sure you check out the resources we make available. So codeLive is run by other developer advocates, and we cover topics like Lightning Web Components, Apex, Agentforce will be a big topic, prompt engineering. So come back to check your regular stream. Don't forget to check out the dev community online. We have YouTube videos available on the Salesforce Developer YouTube channel, as well as developer.salesforce.com, where we link all of the videos and blogs too. So check it out. I'm going to check the chat one more time. Looks like I've covered everyone's questions. So in that case, I will say good night to everyone, or good morning, and I'll see you in the next session.